To begin, it is important to note that a two-way probability table is important to differentiate different variables and how many of each variable is present and how those variables affect each other, which is why the independence test would be related to it, because an independence test proves whether or not two variables are reliant on each other. And then when trying to figure out probability, something that you might face is a probability equation with a given line, which is just a line, which implies that one variable is a given variable, and you're trying to find the probability of variable A given variable B.
A random survey was conducted asking men and women if they preferred the early morning or the late night. 80 women were interviewed. 23 said they preferred the morning. 85 men were interviewed. 12 said they preferred the morning. Part A. Show the data using a two-way probability table.
Late night.
I personally prefer late nights because I just have more energy and there's more stuff to do in the night than there is in the morning.
I prefer late night.
Whoever picks the early morning, I disagree. I pick late night.
So the way you set this table up is you're going to do men and women as they're separated in that way, and then morning and night, as that is what we were trying to figure out for the problem, and you're going to have a total across the bottom and a total across the side. And the total number of people in general is 165. The total number of men is 85. The total number of women is 80. And now what we know from the data that is given is that 12 men said that they preferred the morning, so we'll put that. And then we know that 23 women preferred the morning, so we'll put that too. And based off of the fact that we know that, that also means that there are 73 men that prefer night and 57 women that prefer night, which means the total number of people that prefer night is 130, and the number of total people that prefer the morning is 35.
100% late at night. Definitely.
Late night because that's when.
Late night because it's more of a vibe. It's so dark outside and your lights look like this. Most people are asleep, so it's like you're the only person awake. All the people with the Chinese letters in their gamer tags are on Call of Duty. It's fun.
Part B asks if being woman and preferring the late night are independent. By asking us this question, we are not going to reply with a simple yes or no. We actually have to use the formula and fill out the equation. Alright, so the equation for this problem will be the probability of A and B equals the probability of A times the probability of B. If this statement is true, then it is independent. So we are looking for the probability of woman and preferring late night, and then we do that is equal to the probability that is a woman and the probability that they prefer late night, which will end up being 57 over 165, because we are looking at the probability that they are both fitting in the woman category and the preferring late night category. And then you're going to do that over the total of 165 possible people. And then the probability it is woman, 80 over 165, because that's the amount of women we have in this study. And the probability that they prefer late night will be 130 over 165, because we have 130 people that prefer late night in this study. And then after we calculate that, we see that those two values are not equal, which also means that it is not an independent situation. Problem C is asking what is the probability that they prefer late night and, which is what N stands for, and is a woman.
Personally, I prefer when it's nighttime.
Late night. Unless I've stayed up all night and then it's the early morning. That's the only exception.
For C, you can simply look at the table and figure that out. But then for D, we are looking for the probability that they prefer the late night or they are a woman. And so for this, you're going to have to use another equation. There are two different equations for this one. It depends on whether or not the situation is mutually exclusive. In the situation we are looking at, it is not mutually exclusive, which means that we need to subtract the probability of A and B. occurring at the same time. And so after we do that, we have 130 over 165 plus 80 over 165 minus 57 over 165, and we come up to 153 over 165. And if you want to fact check that, all you have to think of is the only group that does not fit the situation is men that prefer the morning, which is 12 people. So 165 minus 12 is also equivalent to 153, which would give you the same answer. For E, we are looking at the probability of preferring late night given the person is a woman. And so that means that our denominator is going to be 80 because we're just looking at women. And then our numerator will be 57 because we're looking at the number of women that prefer night.
Do you prefer the early mornings or late nights?
I prefer early mornings, and the reason being is I like to get up early in the morning, get everything done, go into the stores before the crowd gets there, and that way, if I get it all done, I have the rest of the day to play.
That is all that I have for you now, and remember that early mornings are the best.